So let's elaborate on the max min com principle that I present in the previous video. So remember, maximize the systemic variance. Okay, so let's look at that first. Okay, maximizing the systematic variance, not systemic, systematic. Okay, now what does this entail? It means that we want to widen the range of values of the research variables. Okay, so which means you need to make sure you take samples that are representative of the broad spectrum of the components of your population. Because if the independent and the dependent variable are not so different from one another, then you are minimizing the systematic variance. So if you have an experiment that you are conducting where you actually manipulate the independent variables so as to measure their impact on the dependent variable, you want to make sure that you have the dependent variable and the independent variable, you want to make sure that they are quite different. Okay, so let's take an example. You have a maize plant. You have probably a maize, a different maize varieties, or different types of let's stick with the maize example because it's easier, it's not messy. So you have different variety of maize and you want to look at how they respond to different level of fertilizer application at different stages of their life. You don't want to be measuring difference in application of 1 milligram differences. You want to see if you apply 2 kilograms per hectare, or 5 kilograms per hectare, or 10 kilograms per hectare, or 20 kilograms per hectare. You can see the difference are quite marked. So you can also be able to see how they contribute. Imagine if instead of going from 2 to 5, I go from 2 to 2.1, 2.2 kilogram per hectare, 2.3. The gap is so narrow. So if there is a little bit of error in my measurement, I won't be able to detect how that changes, the changes in the application is contributing to the changes in the yield that I'm getting from each of the different variety. Also, if we pick the maize variety, you don't pick a maize variety that is so similar to one another. You want to make sure that there is high variability in the independent variable. Okay, so the variable that are constant, that are the independent variable, you want to make sure that there is high variability in them, because if there is high variability in them, there is going to be definitely, most likely, let me not say definitely because it depends on the experiment you are carrying out, it will also create a more or less similar changes or variability in your dependent variable. So that way you'll be able to see how the independent variable are contributing to what you are seeing in the dependent variable. Okay, how they explain the dependent variable. Okay, so remember, the dependent variable are explained by the independent variable. So if you are not doing an experiment, okay, in this case you are going to the field, you are collecting information, maybe a questionnaire survey, you are asking people about something, let's say their perception about something, what they think of COVID-19, what they think, what are their perception about sexual violence or conflict, ethnic issues, the acceptance of people who are not from their area or from their ethnic group, and things like that. You must make sure that you have samples drawn across different areas within your study area in terms of male, female, young, old, middle age. So that way you will be able to get a good representation of the entire population. So your sample will be quite representative. That is one of the ways by which you will be able to ensure that you are maximizing the systematic variance. So take note of this. There are situations where you will, if you are doing experiment, but most of the time if you're in social sciences, you might not be doing experiment, but there are factorial survey experiments, which is a new technique and is growing. So it combines experimental design with non-experimental design. So it's a quasi-experimental design, but I will not go into that for now. But just remember, you need to maximize, and if you need to maximize systematic variance, these are the way you do it. You make sure that you have high variability in the independent variable if you're doing an experiment, and if you're doing non-experimental designs, you must make sure that you select subjects that span across what is obtainable within the population you are drawing the sample from. So if we go on to the next, max, mean, con. So the next variance that we need to correct for error variance, measurement error. You need to minimize error in your measurement, and that has to do with designing proper measurement tools. Your instrument, your tools for measurement must be properly designed, especially if you are doing non-experimental design where you're using questionnaires or something similar, as we all most of the time do. But if you are doing experiment, which means your instrument must be properly calibrated, they must work accordingly, they must be fine-tuned to measure exactly what they, because if they are erroneous in their measurement, that goes also into your conclusion, and it goes also into once it goes into your data, it will surely goes into your conclusions. So what are the sources of error? When you design your instrument poorly, poorly designed measurement instrument, it can bring about instrumentation error. If your study subject provided erroneous answers, that is response error. And there's also some contextual factors that may reduce sound or accurate measurement based on the capacity of the instrument to measure accurately. For example, if you go on to administer questionnaire, recently I was sent a questionnaire to fill online, and most of the questions were the statement that I was supposed to respond to in terms of strongly agree, the range of opinion, the Likert scale. They were asking questions about the entire country in terms of COVID-19, and they want me to state my opinion in terms of strongly agree, disagree, and so on. But I do not have information about the entire country. I have only information about the state that I'm residing. So it becomes really difficult for me to actually to provide a very accurate information. So the instrument has a problem because it was not designed to measure accurately what is going on. It would have been stated clearly in that instrument that looking at your state, COVID-19 response is so and so, state your opinion, strongly agree on it. That will be much better, because the context from which the question is, the statement is being presented to me for me to answer strongly agree or disagree is not correct. So I will not be able to give them accurate information about what I can't give them any good information, since I do not know what they are really asking me to present an opinion about. So take this into consideration when you are designing your instrument for your survey. So how do we minimize these sources of error? Instrumentation error, response error, or error in terms of the capacity of the instrument to collect accurate information, or we could look at it as contextual error. Okay, how to minimize it? Increase validity and reliability of measurement instrument. We talked about this when we are in one of our previous videos. Validity, the ability of the instrument to actually be measuring what it's supposed to measure. Look at the example I gave just a few minutes ago relating to the context. The context was not proper for the question that is being asked of me. So let me give another example. If you present statements, items of a questionnaire to people to give you their opinion on the strongly agree, agree, disagree, strongly disagree scale, if the statement is not well prepared or simple enough for people to quickly understand, if you use complicated language and incoherent or big words because you want to show how intelligent you are, it becomes really difficult for the people you are presenting the questionnaire to really give you a good opinion or the true representation. This has to do with the reliability now, because then if you give the questionnaire to somebody today and they understood the statement as this and they say strongly agree today, and tomorrow they read the same question or the same statement, they might look at it, oh, maybe they mean this, and then they give you strongly agree. Yesterday they said strongly disagree, today they say strongly agree. It means that that instrument is not reliable, because every time somebody read that statement that you ask them to provide an opinion about, they interpret it differently. So it means that that instrument is not reliable. Valid has to do with the instrument measuring what it's supposed to measure. If you are measuring perception, the instrument must measure perception. If you are measuring attitude, the instrument must measure attitude. Not that you are measuring attitude, but you are asking questions about behavior, or you are measuring actions taken instead of measuring attitude. So the instrument must be valid in the sense that it must measure what it is meant to measure. Measure variables under an ideal condition. Okay, under ideal condition as much as it is possible. It is not sensible for you to go and ask question for somebody from present a questionnaire for somebody that is in a hurry. So he's just going to just give you any answer or just fill the questionnaire so that you can go and leave them alone, so that they can just go away. You can just go away and just take whatever you want to take from them and go. You are not going to get very good and reliable information there, even though your questionnaire might be valid and reliable, but you are presenting the questionnaire, the survey, not under the ideal condition where the person will be able to give you reliable information. So take note of this.